Hello, today we're going to look at the law of cosines. So we looked at the law of sines earlier and we solved the triangles of cases 1 and 2. So now we're going to look at what's called the law of cosines for cases 3 and 4. So the law of cosines is a squared equals b squared plus c squared minus 2bc times cosine of a. You can do this with any angle you're looking for. You just have to remember that the equation you want involves the side squared equals the blah, 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 with the angle that's opposite it. So a squared on the left, cosine of a on the right. B squared on the left, cosine of b on the right. C squared on the left, cosine of c on the right. And if your angle here was 90 degrees, then you'd have exactly the Pythagorean theorem. So Pythagorean theorem is actually a consequence of the law of cosines. And the law of cosines is for any triangle, not just a right triangle. So we're going to see how we use this in the cases 3 and 4 of solving triangles. So case 3 is two sides and the angle between them. So again, that's the information you're given. So as an example, we're given side A is 45, side B is 67, and angle C is 35. And we want to solve the triangle, so we want to find the remaining pieces of information. So here is a possible picture of our triangle. And just like with the law of sines, I suggest that you write down this triangle so that you can refer to it back when we're doing the math. Okay, so hopefully you have it written out next to you. And the first thing we're going to do is we're going to find the third side, C. So we're going to use the law of cosines that involves the angle we want on the left. So the side that we want on the left. So c squared equals a squared plus b squared minus 2ab cosine of c. And if I plug that all into my calculator, I remember order of operations. I'm going to get 1574.513. Use as many decimals as the calculator gives you. Don't round in the middle. Just keep using the same answer. And then c is, of course, the square root of this number, which is 39.68. Now that we have side C, we're going to use the law of sines to find the smaller angle. So in this case, the smaller angle is A. Remember that the smaller angle is opposite the smaller side. So side A was smaller than side B, so angle A is smaller than angle B. So we set up the law of sines. Sine of A over 45 equals sine of C over C. So sine of 35 over the 39.68 that we just found. We're going to solve this the same way we did using the law of sines. We'll multiply both sides by 45 and then hit it with sine inverse. And we get out that A is 40.58 degrees. Now the reason we want to use the smaller side, the smaller angle here, is that if we remember from Tech 1, sine inverse will only give us angles in quadrants 4 and 1, so from negative 90 degrees to 90 degrees. And if angle B were obtuse, if it were bigger than 90 degrees, then the law of sines wouldn't give us that. It would give us the equivalent angle in quadrant 1. So we really have to make sure that when we're doing the law of sines here, we're using it on the smaller angle. And then our last thing is to find the third angle. And we're going to use the fact that the angles sum up to 180. So B is 180 degrees minus the 35 degrees minus the 40.58 degrees. And that gives us the 104.42 degrees. And again, the law of sines wouldn't have given us that. It would have given us something like 76 degrees. So it would have given us the quadrant 1 angle that's associated with it. Okay, so let's try another example. Given that A is 10, B is 45, and C is 100, we're going to solve the triangle. And again, here is an example of what the picture could look like. So again, you might want to write this down in your notes before moving on. So you might want to pause it now. Okay, so let's move on. Again, we're going to do the same method. We're going to find the missing side, which is side C. And again, we'll set it up. C squared equals A squared plus B squared minus 2AB cosine of C. Careful of order of operations, you should get 2,281.283. And then to get C, we'll square root it. And C is 47.76. Next, again, we'll use the law of sines to find the smaller angle. In this case, since C is already 100 degrees, I know that there can only be one angle that's obtuse, if there is one. So I know that A and B are both less than 90, but just to keep on the same track, I'm going to do the smaller angle anyway. So sine of A over A, which was 10, equals sine of C, which is 100, over C, which is 47.76. And again, to solve for A, I will multiply both sides by 10, and then hit it with sine inverse. And I get that A is 11.90 degrees. It's a fairly small angle. And then to find the third angle, again, we use the fact that the sum of the angles is 180. So B is 180 minus 100 minus 11.90, and we get 68.10 degrees. Remember, you can always check to make sure that your answer makes sense. Is the smaller angle actually the smaller angle? Is the side opposite the largest angle the largest side? So in our case, our largest angle is C, which was the 100 degrees, and our largest side is also C, 47.76. Our smaller angle was A at 11.9 degrees, and it's also the smaller side at 10. I could also actually check it and try the law of sines with two other sides or letters. I use the law of sines with A and C. I can try it again with A and B, or with B and C, and make sure that those are roughly equal. We did round, so they won't be exactly equal. But you can always check your answers. Okay, so that's the cases for case 3. Next, we're going to look at case 4. So case 4 is we're given all three sides. So as an example, we're given that A is 49.3, B is 21.6, and C is 42.6. Again, here is just a basic rendering of what the triangle could look like. Okay, so with case 4, the first thing we're going to do is we're going to solve for the largest angle with the law of cosines. And again, I want the largest angle because later when I do the law of sines, I want to use the smaller angles. So we're always going to look for the largest angle first, and we're going to use the law of cosines. So the largest angle is angle A, so I'm going to use the law of cosines that involves cosine of A. So that's A squared equals B squared plus C squared minus 2BC times cosine of A. Be really careful here with order of operations. I would have to do this multiplication before I can add it to the other things that are being squared. So because here is my unknown, I want to get rid of those two numbers first. I'm going to use the law of addition. I'm going to subtract the 21.6 squared, subtract the 42.6 squared. And then once I've done that, I will divide by whatever number this is. Okay, so you have to be really careful when solving for unknowns. So cosine of A should be 149.17 divided by negative 1840.32. A lot of people will forget that there is a negative sign here. So again, you're dividing by a negative 1840.32. If I know what cosine of A is and I want to know what A is, I hit it with cosine inverse. So A is cosine inverse of that fraction. Don't forget the negative. And I'm going to get 94.65 degrees. The fact that what's inside my argument is negative means my angle is bigger than 90, right? It's a quadrant 2 angle when cosine's negative. Okay, so it's 94.65 degrees for my largest angle. Next, I'm going to use the law of sines to find a second angle. And again, since I already did the largest angle, it doesn't matter which angle I do now for the law of sines because I know they can't be obtuse. I know they have to be a quadrant 1 angle. So I tend to go alphabetically, so I'm going to do B next. So sine of B over side B equals sine of A over side A. And again, we're going to multiply by the denominator and then hit it with sine inverse. And we should get B is 25.89 degrees. And then to find the third angle, again, we're going to use the fact that the angles add up to 180. So C is 180 degrees minus 94.65 degrees minus 25.89 degrees, and we get 59.46 degrees. And again, you can check your answer using the law of sines with B and C or A and C, one of those things. So you should always check your answer, make sure it makes sense. And as our last example, we are given that A is 4, B is 2, C is 3, and we want to solve the triangle. So again, if I draw it out, here's a possible example of what it looks like. And again, we are going to find the largest angle first using the law of cosines. And again, our largest angle happens to be A because it's opposite the largest side, which was 4. So A squared equals B squared plus C squared minus 2BC cosine of angle A. Again, being careful, make sure you subtract the 9, subtract the 4, and then you'll be dividing by your negative 12 at the end. So cosine of A is 3 over negative 12. So A is cosine inverse of 3 over negative 12. And again, because it was negative, I know my answer is going to be larger than 90 degrees, so it shouldn't be surprised when it comes out to 104.48 degrees. And then we're going to find, again, just a next angle. I tend to go alphabetically, so I'll do B with the law of sines. Sine of B over side B equals sine of A over side A. And B should be 28.95 degrees. And then we're going to find C. So I'm going to take 180 degrees. I'm going to subtract my two angles that I just found. And I'm going to get 46.57 degrees. Okay, so again, I would check it if I were you. Make sure it makes sense. And then try out the homework, read over the book. Let me know if you have any questions. Good luck.